I don't think that's
All right, let's get started here. So the test on Friday did not go real well. Not real well at all. I really don't know. I mean, there were some people that did well. Yes. I mean, you got your scores.
I don't remember what it was.
I don't remember what yours was.
Yes. No one cares. No one cares.
No one cares until you
passed
fail.
one
That's
test
why
in
you
your life.
fail.
One
test. You said every single one.
Yeah, and then I have gotten through your whole class looking through your work. Okay, so your score may have improved a little bit since the end of the test. Because I went in and gave some additional points if I was able to find some correct work on your papers. Also, after the test, then, if everybody finished in class, you had some time. If you hadn't already completed the weekly air review that was due on Friday, and I watched some people just sit there and play on their phones for half an hour, right, and didn't even bother to do the weekly air review. I mean, that's a 0 out of 5 and a mastery grade. Okay, if you didn't do it. I mean, I reminded you guys every single day last week. You had time in class to do it after the test. I really don't know what else to do for you. I mean, some of you are just like actively refusing to do that stuff, and I mean, you're going to fail. There's no other.
And that's the biggest help that you can do for yourself for that air test. Those edge elastics, that is the best way to prepare.
Yeah. So there is another one up for this week. 5 questions, due on Friday. It has to do with population density, which is something we haven't actually talked about yet this year. It's something you've done before. It's a super, super simple concept. If you don't remember how to do it, there's a 2-minute video of me explaining how to do it for each question on there. And so that's due on Friday. Get that done. Okay? Today, then, we're going to start Chapter 6. Right? Chapter 6 is mostly about quadrilaterals, but this first section is going to be about angles in any polygon. And so, phones need to be away. I shouldn't have to say that ever, but it's getting annoying as well that I have to say that constantly. So the big idea that we're going to look at today is angle measures in polygons. Right? This first part up here kind of explains where this formula comes from. Right? This formula just says the sum. What does sum mean? Yeah, the answer to an addition problem, right? So sum means we're adding a bunch of stuff together. And so the sum of the interior angle measures of an n-sided polygon is that number of sides minus 2 times 180. Right? So, for example, we know that a triangle adds up to 180. Right? The 3 angles in a triangle add up to 180. So if I say, well, to get the sum of those measures, I'm going to take 3, the number of sides, minus 2 times 180. Well, 3 minus 2 is 1. 1 times 180 tells me the sum of the angles in a triangle is 180 degrees. If I do that for a quadrilateral, right? A quadrilateral is a 4-sided figure. Well, if I do 4 minus 2 times 180, that'll be 2 times 180. 2 times 180 is 360. So for any 4-sided shape, the 4 angles inside will add to 360 degrees. This formula lets us do that for any convex polygon. Right? So I guess another vocab word that we should talk about is convex. Okay? You may have encountered this in science class, the difference between convex and concave. And I don't know if it would have crept up in a math class before or not, but probably in science class. Does anybody know the difference between convex and concave?
Isn't concave where it goes in, and convex is where it like pushes out?
Exactly. Right? Concave, it goes in, it caves in on itself. Convex is where something is pushed out. So what the only importance here, okay, we're assuming that all of these polygons are convex. A concave polygon would just be, something like this that caves in on itself. And then we can't really talk about the angles because this angle here would be greater than 180 degrees. We're not going to get into stuff like that. Okay, so we're assuming that everything we're talking about is convex, meaning that there's nothing like this where it caves in on itself. Okay, so nothing like this is going to show up. So in this first example, it just says a convex polygon has 13 sides. Find the sum. So what all 13 angles inside will add up to. Well, we're just going to use this formula. The number of sides minus 2 times 180. So I'm going to have 13 minus 2 times 180. So what is 11 times 180? 1,980. So no matter what this convex 13-sided shape looks like, I know that all 13 angles inside will add up to 1,980. Okay. So let's try a couple of those real quick. Okay, the first 3 exercises right here, find the sum of those measures of first a decagon. And if you don't know what a decagon is, we've got this little chart over here that tells us how many sides each of these shapes has. Okay, and then once we get past 12, we don't really have names for them. We just say, well, it's a 16-gon, meaning a 16-sided shape, or a 30-gon, or a 30-sided shape. Okay, so take a couple of seconds here, use your calculator, and figure out the sum of the measures of these angles, or of the angles in these polygons here.
Because you get 8 times 100. 8 times 8 is 600.
Wow. Interesting guess the next one. You need to slow down.
I didn't put any of the answers up yet.
You better not. He's doing it, kids. Here he goes. There he goes. You better slow down. Hey.
Well, just don't look up here yet.
Stop.
Now you don't know how to do those. Just, just 1, 2, 3.
I already knew that.
You bet what?
Whoa.
Those know.
You're eating ass like Popeyes? That's it? See those?
Yes, it is.
Huh?
Yeah.
Why?
Why else would
So, Did we get 1,440 for a decagon, 2,520 for a 16gon, and 5,040 degrees for a 30-sided shape?
Guys, we need to pay attention. You guys are squirrely.
So these measures, or these large degree sums, are what all, in this case, 10 angles would add up to, what all 16 angles would add up to, and what all 30 angles in this shape would add up to. Alright? Questions so far? So let's jump back up to example 2 here. Okay? This says measure. Actually, we're going to do these ones first, and then we'll jump back up to example 2. We're going to jump down to 7, 8, and 9. It says find the measure of each interior angle of each regular polygon. Okay, so first, what is interior angle? The inside, the angles on the inside. What does regular polygon mean? That's going to be a big key for this type of problem. Well, so regular, we know are going to be convex. So regular gives us even more information. What does a regular polygon mean, Sebastian? No, not necessarily. We could have a regular 5-sided, a regular 6-sided shape. I think we mentioned this at one point a while ago, but we haven't really talked extensively about a regular polygon. Amanda? Yeah, regular means all the sides have the same length. Okay, so you can make a note of that. Okay. And not only are all sides the same, but that also then means all angles would be the same as well. So we can say all sides and angles are the same. Okay. So what this question is saying is we've got, first, for number 7, an octagon where we know all the angles are the same. Okay, it's a regular octagon. How many sides are in an octagon? 8. Right, so 8 sides, which also means 8 angles. 8 sides, 8 angles. So what I want to do here is take this 8-sided shape and figure out each individual angle on the inside. Well, we know how to find what all of them add up to. Right? That was the formula we just worked with, the n minus 2 times 180. How would I then find what each individual angle would be? Divide by the number of sides. Exactly. So our formula for ones like this is going to be just take n minus 2 times 180 and then divide by the number of sides. Okay, so find the sum of all the angles and then divide by the number of angles. Right, so in this case, we'll have 8 minus 2 times 180. And then take that and divide it by 8. So what do we get for that? 135. So what that means is if I were to draw an octagon where all the sides and angles were the same, each angle on the inside would measure 135 degrees. Questions on that? Okay, why don't you guys try numbers 8 and 9? Okay, find me the measure of each angle of a regular pentagon and then of a regular 15gon.
Dude, you're just trying to get their attention on you. It's not working. I know you are, but it's okay. It's okay. I don't care if you're gay. I'm still gonna be your friend. I'm still gonna be your friend.
If I'm straight, I offend you.
I'm still gonna be your friend. I'm still gonna be your friend if you're gay. It's fine. I don't care. It ain't gonna bother me. It don't bother me. It's fine. It's fine that you're gay. I'll still be your friend, I promise. If you don't want me to be your friend because you're gay, it's fine. But I'll still be your
I
friend.
don't want to be friends with you.
Okay.
You're the gay one.
I get it. You can't resist because you're gay. You can't resist being friends with me. It's fine.
It's his phone. Snap it this way.
Look, the gay person has anger issues though.
Fatch, I'm really gonna punch you. Because he won't quit calling me gay. Well, I'm saying how it is. If anybody gets offended, we're gonna get up there.
Settle down.
You settle down. You don't want to get on the fire over there.
Alright, for number 8, did we get 108 degrees?
Yeah,
And number 9, 156 degrees?
Yeah, you know.
Alright.
Okay, are you?
Questions on this idea? Alright. Now, let's jump back up to example 2. So, example 2 says the measure of an interior angle of a regular polygon is 120. Find the number of sides. So this is kind of like what we just did, right? We're talking about regular polygons, but this time we know that each individual measure is 120. And we want to find n, the number of sides. So we're still thinking in terms of the formula we just came up with, right? This n minus 2 times 180 over n, and that equals the individual angle measure, right? So if we think about the information we have here, we have the individual angle measure, and we want to solve for n. So in this case, I'm going to say, well, I know that this value, what this whole thing is equal to, is 120. Okay, so this is going to be my original setup. If I know the angle measure, and I want to solve for the number of sides, okay, this is my initial setup. How would I solve something like this for n? Best?
Trial and error.
No, we're not going to use trial and error.
Just go home. Just go home.
Just go home.
Yep.
Yeah. So how are we going to go back to this? So whenever we have a fraction or division, right? A fraction is just division. I want to undo that. I want to get rid of the fraction. How do I get rid of the fraction? Multiply by, yeah, so I'm going to multiply by whatever's in the denominator of the fraction. In this case, that's n. So I'm going to multiply both sides by n. What that does over here, that cancels the n's out. Right? If I'm multiplying and dividing by the same thing, those will cancel out. And I'm just going to have n minus 2 times 180 equals 120n. Now what? Now what?
Multiply by 2. You're going to multiply the 180 by.
Yeah, so let's distribute this 180 through the parentheses here. Okay? 180 times n will just be 180n. And then 180 times negative 2 would be negative 360.
I don't even know where you're at.
you lost.
I can't find the way home sometimes. I don't even know.
Okay, yeah, so now we've got an n and an n. We've got n's on both sides of the equation. What do I need to do?
What's your problem?
Yeah, I need to get them on the same side. So
You gave two now?
since I only have one number, and the number is already on the left side, I'm probably going to want to bring my n's over to the right side, even though it's going to create a negative n. Okay, it's going to save me a step. So I'm going to subtract the 180n over, and we'll have negative 360, and 120 minus 180 is negative 60n. So now, the final step to get n by itself, divide by negative 60. Negative 360 divided by negative 60 is going to be 6. A regular polygon, where each angle is 120 degrees, has 6 sides.
What's the point of doing this all?
Dude, from 1 second, you look back, there's like 8 more things. That's what it was just like.
I mean,
I said, I'm going to beat you up. I look back, and it's
Just kind of,
6 more.
if you memorize n minus 2 times 180, you end up getting you this, 180n minus 360.
Sure.
I guess you could save yourself a couple of steps.
I got 4
Yeah, I mean, you could use trial and error, because you know that this is going to be a whole number. You know that you can't have half of the size, right? So you could just take this n minus 2 times 180 divided by n and start plugging numbers in for n until you get 120, because you know that's going to be a whole number, so you're not going to have a whole lot of possibilities. Okay. So why don't we do another one of these together? Okay, let's do another one of these together, and then see if we can try a couple. So these ones are like numbers 4, 5, and 6. Let's do number 4 together. Okay, so we're saying we're using this idea of n minus 2 times 180, and then dividing by n, right? The sum divided by the number of angles, and in this case, we know that that's going to equal 150. So to solve this, I want to get rid of this fraction first. So I'm going to multiply both sides by n. Those n's then cancel. That's the whole point of multiplying by the denominator. We're multiplying and dividing by the same thing, that cancels out. So then, if you want to save yourself a step, you could go ahead and distribute that 180 here in this step. Okay, so I could say I'm going to multiply that 180 through, so 180 times n is 180n. 180 times negative 2 would be negative 360 equals 150n. So now I want to get the n's on one side of the equation. So I'm going to subtract the 180n over to here. We get negative 360 equals 150 minus 180 is going to be negative 30. Yeah, no, these ones are kind of crunched in there. Then the final step to get n by itself would be to divide by negative 30. So negative 360 divided by negative 30 is going to get me 12. So that means an angle or a regular 12-sided shape will have angles that each measure 150. Right. Questions? All right. you guys go ahead and try 5 and 6. Okay, find me the number of sides that each of these regular polygons will have.
Get like half of that. When you're doing it, you know it shouldn't equal like out the end.
Yeah, you know that you're going to get to here.
Yeah.
And minus 360.
You just had the blue the other day. Why don't you say something?
I always do.
All about
How much do I have to
Hey, bro. I got 18.
Oh.
You got 18, right? Well, good. Just did it?
Listen, no one cares about the fucking soldiers that died yesterday. They died yesterday.
For number 5,
No one cares about them, but they all care about
for number 5, I think we should get the N is 18. And number 6, we should get N is 72. Okay? So each angle in a 72-sided regular figure will be 175 degrees, and each angle in an 18-sided regular polygon will be 160. Not for one that are that. Alright, let's take a look at number 10 now. Okay, on this one, we have a 5-sided figure. Okay, so a pentagon. It's not necessarily a regular pentagon, right? All the sides are not the same length. It's just a pentagon. And it just says find the value of x. And we're given different expressions for all 5 angles. Any thoughts on how we could set up and solve an equation here? So yeah, we're going to add all 5 of these together. Yeah, what do we set that equal to then?
Wait, so I figured, so there's 5 angles, so you just put the 5 angles into the thing, subtract 2, multiply by 1.
Right. Okay, so
actual word has to equal to like.
Yeah. Okay. So in this case, since we have a 5-sided shape, we want to find the sum of all the angles. Right? So we're using this formula. This formula, the n minus 2 times 180, tells me the sum of all the angles. So if we have a 5-sided shape, and I do 5 minus 2 times 180, that's going to be 3 times 180 gets me 540 degrees. So I know all 5 of these angles are going to add up to 540. Okay, now I cannot just divide this by 5 because these aren't all the same. But what I can do is add all 5 of these together and set that equal to 540. So we'll have 4x plus 5 plus 5x minus 5 plus 6x plus 10 plus 4x plus 10 plus 7x. All 5 angles added together. And that's going to equal what we know the sum of any pentagon to be, 540. Okay, so for a problem like this, you need to look at how many angles or how many sides there are to first determine what we need to set that equal to. Okay, then add them all up, set them equal to that value. So we just want to combine our like terms now. So 4x and 5x is 9x, 15x, 19x, 26x. I combine all my x's. Then my numbers, 5 and negative 5 is 0, plus 10 is 10, plus 10 is 20. So 26x plus 20 equals 540. Subtract 20 over. Get 26x equals 520. Divide by 26. And we get 20. Would that be my final answer? Yes, right? So it just says find the value of x. So x equals 20 is my final answer for this problem. Right? We okay with something like that? Any other questions? Okay. All right, go ahead and flip over to the back. Okay, the back is a lot easier. Yeah.
No, I have 2 of these.
It says, what will be put in the galleries? It says, the customer construction. I can't say I'm tired if I want mom making a competition of who is the most tired.
All right.
And who has more of a reason.
On the back, we are finding measures of exterior angles of convex polygons. Okay? Measures of exterior angles. So this piece up here, okay, makes exterior angles pretty easy. This just says the sum of the exterior angle measures of any convex polygon is always 360. Right? The sum of the measures of all the exterior angles of any convex polygon is 360. So if we remember, an exterior angle is just when we extend one of the sides out, the angle that's created is an exterior angle. So if I were to add all of those angles together, it's going to be 360 every time, no matter how many sides the shape has. It's always going to be, they're always going to add to 360 degrees. Okay? So, example 1 says find the sum of the measures of the exterior angles of a 27 gun. Nope, 360.
You do 360 divided by 27.
Sum just means what do they add to? They add to 360. That's the answer. Right? Sum means what do they add to? The exterior angles always add to 360. Okay? Number 2 then.
It's easy for him to do that, but watch, he's going to make us do it.
It's not. If it says find the sum of the measures of the exterior angles, the answer is 360. So our answers for 1, 2, and 3, the exercises, 360. Okay? The sum of the exterior angles. Okay, the sum of the exterior angles is always 360. Okay, well now, in example 2, it says find the measure of each individual exterior angle of a regular figure. Okay, so here we're talking about a regular hexagon. So hexagon means 6, right? 6 sides, 6 angles. So we already know that all exterior angles add to 360. It's going to take 360 divided by 6 to get each individual measure. So 360 divided by 6 is 60 degrees. So this angle would be 60 degrees. Now, this is also then, could be looked at as a shortcut to find the interior angle. If I know the exterior angle is 60, what's the interior angle? 120. Right? So the question didn't ask us for that, but if we want to find the interior angle, once we know the exterior angle, we know those just add to 180. Okay. Questions? Okay, so the exercises down here, okay, are just super simple practice on that, right? Find the measure of each exterior angle for each regular polygon, so we know they're all the same. So for each of these, I would just take 360 divided by the number of sides. So 360 divided by 12, 360 divided by 40, 360 divided by 6. Okay. Questions on any of this stuff?